Welcome to the second lecture of mass transfer operations for the purpose of gate preparation. In this, as we have seen earlier in the previous video, mass transfer occurs in various operations such as distillation. Okay, distillation is nothing but a gas liquid operation. Distillation is a gas liquid operation wherein general diagrammatic representation of the distillation would be with a single feed stream, feed containing of two or more components. We have the top product known as distillate and the bottom product known as residue or the bottoms. Above the feed plate, the portion, the section above the feed plate works as absorption section or rectification section. The portion below the feed plate act as desorption section, or I should specifically say, if it is absorption, I should say it is stripping operation. The opposite of absorption is stripping operation. Otherwise, exhaust section. This is exhaust section. This is enriching section. We'll go details into this particular distillation while dealing that particular topic. Second one is absorption operation. In this absorption operation, or this absorption operation is also gas liquid operation. The transfer, the mass transfer, the transfer is from gas phase to the liquid phase. The general arrangement of this particular operation would somewhat look like this. This is, a tower. In the bottom of the section, gas is entered. Top of the section, liquid is entered. They both come into contact here. And the liquid, comes along with the solute component, the solute from the gas. And the gas free of the solute, or from which our solute component is absorbed in the liquid, is leaving as the exit gas stream. So to this place, it is clear to all of you. Okay, now next, let us come to the next operation here. The next operation is drying operation. So what is the first one? First one is distillation. Second one is absorption. Third one is drying. In the drying operation, or rather, as it is, if you see the phases involved in this, solid, liquid, and gas phase. All the three, or you can say specifically vapor also, we can say. So if I take a dish containing solid, wet solid, and we are supplying a heat source through a cross circulation or through circulation of the hot air or stream in it. The solid, if you say, it is a solid phase. I am saying wet. It might be wet with moisture or any solvent. So it is liquid. Once you are trying to dry this particular substance, there will be vapor which is releasing. So that is vapor. And the gas in a hot air is a gas stream. This is a gas stream. So totally solid, liquid, gas stream. Next come to the next topic of mass sensor operations. Another one is, see, I have already told you that I am utilizing textbook, or I am following textbook written by Gyncopolis. Liquid extraction. What is the next one? Is liquid extraction. So what happens in this? What happens in this? In this, there is one stage to which, suppose say a feed containing A and the C, our constituent, to be extracted using the third component known as solvent. So there are two phases coming out. Number one is extract phase or solvent rich phase. That means it will be having B and it carries along with it C. See, B carries along with it the B. The other phase is known as raffinate. It contains A, that means the diluent or the apart from the C solute. It contains small quantities of C, small quantities of B. Okay, next. If you see the next operation, what is the next operation? Next operation is adsorption operation. This we can also say it is a fluid solid operation. See, very simple. This fluid can be liquid that transfer to the solid. That means mass transfer is from liquid phase to solid phase. The fluid can be vapor. The mass transfer can be to the solid phase. The fluid can be gas stream. The mass transfer is from gas stream to the solid stream. The simple example of this is that if you take what you call small muddy water, this is muddy water here, you have muddy water, and you add alum to it, alum to it, you add alum to it, all the solid particles are, occludes, or they come as part of the affinity towards this particular substance called alum. Then the whole water will become clear liquid solution. Now the Third one or last one. What is the first one? Distillation. Second one is absorption. So first is this. Second, absorption. Third, drying. Fourth, liquidical extraction. Sixth, adsorption. The opposite of adsorption is leaching. Okay. Yeah, we'll see that also in the next class. Now that's seventh one, or am I right or wrong? Four, one, two, three. Yeah, this is four. Sorry. So this is fourth one, and this is fifth one. Now we are at sixth. Okay, sixth. What is sixth? Membrane processes. Nowadays, industries, the revolution has come up to reduce the energy consumption. So they are using membrane processes. That means you separate the solute plus solvent using a membrane in between and you get the output. That means you retain solvent or you retain solute based upon this membrane properties. Just imagine a sponge, a sponge when squeezed in the water, or when you suppose say when you dip that into the water and then take out and squeeze it, you know, you find certain pores in this particular membrane. So that is nothing but it is acting like a membrane. So similarly, large scale also, or presently in the R&D stage, we can say some of the R&Ds are utilizing it also to separate the systems. Okay. With this, we end the lecture 2. We'll go to the lecture 3 for further study. Bye.